So, could this point be a maximum of the function? Well, clearly not if you think about what that means. It couldn't be a maximum or a relative maximum, because if you move in this direction here, if you change your x in this direction, if you move in this direction, the value of the function increases. So clearly it gets bigger if you move in, if you change your x coordinate in this direction. So this is clearly not a maximum. Also, if you change the y coordinate in this direction, the function is going to increase. And this means that if you change your x and y directions in any direction between here and here, the function is going to increase. Okay? So, okay, so, yeah, if we change the x and y coordinate in any of the yellow directions up here, function increases. Clearly not a maximum. And conversely, if we go in any direction between this direction and this direction, the function has to decrease, right? Okay? Now, so we kind of have four quadrants. One quadrant in which we know the function increases, one quadrant relative to this point in which we know the function decreases, and then two quadrants where it's going to go from increasing to decreasing as we go from here to here. We don't know where that line of demarcation would be between where it's increasing and where it's decreasing. Okay? We could find it using what we call a directional derivative, but we're not doing directional derivatives in this course. I don't think. I don't see it in the text. Okay? And that would involve some trigonometry, some understanding of sine and cosine functions and vectors, which is why we don't do it, because we're not assuming that. Anyhow, somewhere between here and here, we have a level curve, don't we? We have a direction in which the function stays level. And somewhere between here and here, again, the same thing. Okay? So, any motion in this quadrant causes a decrease. There is a direction. I can find a piece of color I haven't used. And since the x-slope seems to be bigger in magnitude than the y-slope, the slope in the x direction is bigger than the slope in the y direction, we figure that it's probably going to be closer to the y direction where we have the equality, so, okay. I'll say along some line, the rate of change is 0. Rate of change being indicated by slope, okay? So, any direction here, your rate of change is positive. Any direction here, your rate of change is negative. Between here and here, at some point, we go from positive to negative. So if we go in the direction, either this direction or this direction along this line, our rate of change, at least at this point, is 0. Okay? Now, if we go further along the line, that's no longer necessarily the case. Again, we're just talking about what happens in the immediate, very small neighborhood of this point.